Hi everyone, I'm Karan.
And this is Sai.
And today we are here to present TrainAssist, a tool to help improve training. TrainAssist is a natural language processing tool developed in collaboration with the Center for Addiction and Mental Health. We aim to classify the responses from training surveys and help to derive insights into how training can be improved. TrainAssist will help CAMH in developing their training methodologies based on the feedback received. We have two goals to the project. The first one being survey response classification using numerical and textual data collected from the TIDES training surveys. The second is to perform topic modeling on useful feedback responses to extract themes, topics, to identify areas of improvements. The data was provided by CAMH and it has three parts. The first is user details. The second is pre and post evaluation responses. So these are just the numerical responses before and after the training. And the third is overall feedback. This is the textual data. The pre-processing is pretty much same from the last time. We did manual data labeling into positive and negative responses. We eliminated irrelevant responses. We were left with 384 samples after the pre-processing. In addition to the samples, in addition to pre-processing, we created additional samples using paraphrasing tools for topic modeling. And we also imputed missing numerical values by taking the average of the particular response of the user.
So just to give you an idea of what the textual data looks like, this is a few of the examples of the training data itself. So you have the original sentence and the label assigned is what the manual labeling work we have done. And the useful, not useful is just to give you a context on how the sentences are. So we ran two different experiments, one with the unbalanced data set and one with the balanced data set. So for the balanced data set, we just downsampled the class 1 labels to bring it to an equal ratio. And we used two models, one is for BERT and one is for GPT-2, and we used the same training parameters doing an 80-20 split. So on the overall slide, we got good enough results with the average being around 90%, and on the overall thing, balanced data set slightly performs better than the unbalanced one, and the BERT performs much better than GPT-2 for the training data what we have. So one thing about the training model was we didn't have enough data to test out our baseline model, and that's when we got in touch with CAMH, and they gave us a different assessment which was specific to the nursing assessment, but the survey had a same column of that similar one which was the TIDES, which said that how the training can be improved. And again, we did the same kind of pre-processing for that survey as well, and few of the examples of the original sentences are given below. So we ran our baseline model on both the baseline models on the test data, and the confusion matrix along with the scores are presented below. So overall, the baseline model performed satisfactorily. We received an accuracy of 82, and the recall and precision values are though less, even though it's less. But one thing to keep in mind is that it was fine-tuned on the TIDES data set. So the another idea of approach was to add the numerical data along with the textual data and combine those together to see if the model predicts much better than what we had. So how the numerical data looks like this. They have a set of training questions where they fill in within 1 to 5. And so we used two different combining methods. So the first one was just to use an MLP on the numerical columns. Along with that, we concatenated with the large language models, and we got an accuracy of 0.9. And the second one was to do the same thing, but instead of a simple summation, we took a weighted average, and we got an accuracy of 0.86. And so we'll discuss more about this in the further pack.
So the second goal of our project being topic modeling aims to identify different topics, themes, entities from a given text or corpus. We had to augment the input data using Parrot package and OpenAI GPT-3 Playground. One of the challenges that we faced with our responses was that the responses were really short, and therefore it lacked context, and we also had some fear of overfitting. So we took an approach where we fitted multiple topic modeling algorithms like BERT topic, LDA, and top-to-back. These are the topic modeling results. So we can see that top-to-back presented 2 topics, and BERT topic and LDA were able to identify 5 topics. These are some of the observations. So the room provided during the training was too small, it was hot, and there was lots of external noise. There was no water provided during training, and there was a lack of hands-on training, etc. So the discussion, what we understood from our study was that the baseline model performs satisfactorily, and testing it on the nursing data or the upskills data provided a similar result. Balancing of data did not have a major impact on the performance, and also the pre and post training scores did not help much. We could clearly see that the language model was dominating in the final layer of the combining in the multimodal architecture. So our recommendation for CAMH and for our project would be to utilize the baseline model to quickly and accurately predict to classify the responses, and we also suggest updating the model when new data comes in. Some learnings are that dealing with short sentences in topic modeling can be really challenging, and we can try some other non-ML based approaches. Multimodal toolkit was still a black box to us because of a lack of documentation, and we should focus on the quality of data. These are the links to our models, and thank you.